Hey, welcome back. We have a brand new section here. We're still working with trees, but we're doing something a little different. So tree traversal is what we're going to focus on. And this is the idea of basically given any tree, whether it's a binary search tree or just a plain binary tree that's unsorted, or a ternary tree or some other tree that has any number of nodes. There's no special order, just any tree, all right? Generic tree. How do we visit every node one time? So this is a classic computer science problem. There are many, many ways of doing it. Contrast it with a linked list. To traverse this tree, to visit every node one time, it's very easy, right? There's one linear pathway from here to there. There is no order that you have to decide. There's no decision. It's just go from here to here. So this is unsorted. Imagine, we're searching for a value. We want to know if 43 is in this list. Well, we start here and we go here, here, here. Okay, we found it. Or if we're looking for 99, we would traverse every node. We hit the end, 99 is not in here. Now, when we talk about a tree, it's very different. So this is not a binary search tree. It is a binary tree. Each node has at most 2 children, but it's not ordered in any way. These values on the right are not less than, or they're not necessarily greater than, 10. And the values on the left are not necessarily less than. So no order. We can't use our little shortcuts. If we wanted to find a node, if I wanted to know if 29 was in this tree, we would need to visit every single node in order to figure out that it's not there. So do we start here? Well, it's probably a good place. Do we go left and then sort of work our way horizontally and go horizontal again and keep going down? Do we go all the way down to the end and then come up and then go down and then go back up, go all the way down to the right, and then, keep going down any further branches? It's really difficult to know. There's so many ways of doing it. It's not like a linked list where there's one linear approach. So that's why we have a section on this. We wouldn't do it for a linked list because there's only one way. But with trees, there are many, many ways. And we're going to focus on 4 very commonly known approaches. They have names, these orders. One thing I'll say, this section will take advantage of recursion more than any of the other sections so far. So if you skip the recursion section, I highly recommend you go back and watch that, because this will be a little bit mind-blowing, might be putting it nicely. It also might just be really confusing and not fun. So I would really make sure you understand recursion. You don't have to be an expert, but just know the basics so that when I talk about it, it makes sense, hopefully, if I did a good job in the recursion section. There are 2 main approaches to traversing a tree, something called breadth first and another called depth first. So these refer to the general directions. So when we talk about breadth first search, if this is our tree, imagine just starting at the beginning and then basically working across the tree first. So 10, 6, 15, then continue across. Breadth refers to the breadth of the tree. That's the worst sentence ever. Then there's also depth first search. And there's actually 3 main orders for DFS, depth first search, that we're going to talk about. So the idea of depth first is that you're just going down, like your primary direction is going to the end of the tree vertically and then coming back up, versus breadth first is going across. So one version is something called in order. And that would mean basically starting down here. And then, well, we're going to spend more time. I don't want to just explain how every single one works. I just want to show you there are different ways. So this is in order. There's also a depth first search called pre-order, where we work from 10 down 6, down to 3, to 8, and then we go down the other side and go down 15 to 20. Then there's also post order that looks like this. So we go down to the bottom and we work our way back up like that. So these are all different approaches, different ways of searching, or at the very least, not even searching, just visiting every single node. If I just asked you to print out an entire tree, there's not one easy way or one given solution, right? These values that we're seeing here are the order that we're visiting them. So this would be the order they would be printed out in. And it depends on what you're trying to do, and I'll have a video where I address that. There are certain situations where you might want to use one versus the other. But for now, let's just leave it at the fact that there are many ways of visiting every single node in a tree. In fact, there are so many ways that we have a whole section on it. And this is really independent of binary search trees. It's really just trees in general. But we will be working with our BST class just so that we don't have to duplicate code and, create a new tree class.